So friends, in this video I will be discussing the indeterminacy and determinacy questions of GATE and engineering services. I have divided these into two levels, level 1 and level 2. So what is the difference of level 1 and level 2 is level 2 are little bit questions which are tricky or need observation of some higher degree or which need some better concepts. And level 1 is straightforward, you don't have to require much skill or observation, just go through it and you will get it. So it depends on experience that if you see a question, you make a little bit of observation and try to find out that this is level 1 or level 2 question, and then the approach should be accordingly. I will tell you how to solve the question so that you don't make any mistake in the exam. Okay, so let us take the first question. What it says, the total degree of indeterminacy. So as we have read, these are very simple question. I will do little bit fast, so be tuned with me. So how many cuts I have to make? I have to make 5 cuts. So each cut gives 3, so 15. And what is the hinge? Total member joint at a hinge are 4. So how many additional equation I have? 3. So the total indeterminacy will be 12. Now take the second question. The total both internal and external degree of static indeterminacy. Again it is static indeterminacy. Make cuts, 6 cuts. Okay, so 18 minus 1 minus 1. So 2, so it gives 16. So 16 is the answer. A straight question. The degree of static indeterminacy of this. So for beams we use the simple method. Fix gives 3 reaction, roller gives 1 reaction, so 1, and this roller also gives 1 reaction. So how many unknown I have? 5. Equation available 3, additional equation 1 given by the hinge. So what is the static indeterminacy? It will be 1. Clear? Now come to the fourth problem. So which of the following is true example of static indeterminate beam? So let us take each one. One end is fixed and the other end is simply supported. So this is the beam. Both end fixed. So both end fixed. One hang, the beam overhang over 2 supports. So the beam overhang over 2 supports. Okay, the beam is supported on 3 supports. So beam supports on 3. So this is a unique type of problem in which if you see, none of the beam is statically determinate. But if you see the observation or the thing that examiner want to ask, then what is the best suited answer? The beam overhang over 2 supports. So what the examiner has want to say is that either the loading is vertical or 2 supports mean 1 hinge and 1 roller. So it is understood. So you have to give a little bit of benefit of doubt to the examiner that what he want to ask. So the comedy of that Paul is भावनाओं को समझो. So just understand the bhavna here, that the beam overhang over 2 supports. So overhang over 2 support is the most appropriate answer. Okay, so many a times in engineering services you have to try to understand what examiner wants to ask, because many a times in the question it is not very clear that what he is trying to asking. But by normal practice and by experience you can say that obvious thing he is want to ask. Okay, so there are some questions in my 7-8 year experience. I have gone through lot of those type of questions. So by practice you can also understand this simple concept. Now see the next question. So what is the total static indeterminacy? Again it is very simple. 1, 2, 3 cuts here and 1 cut here. So total 4 cuts will make you the 4 trees. So 4 into 3, 12. Due to this hinge, -1, due to this hinge -1. So 10 is the answer. Simple. Okay. Now see this, which of the following is statically determinate and stable? So this gives 2 reaction and this gives 1. So 3 minus 3 0. So this is statically determinate. What about this? It gives 6 reactions. You have equation available 3 because of hinge -1. So 2. So this is indeterminate. Okay. So this is indeterminate. In this, if you have seen my lecture, then you will find that in one point I have discussed that if the reaction are concurrent, then the structure is unstable. So in this, the examiner has has shown you that these two reactions are concurrent. Hence, this is a unstable. Now come to the fourth one. It is also same. I have discussed in my videos that if all the reactions are parallel to each other for general loading, is it okay? Then that structure is unstable. This structure is unstable because it will move on the roller. So what will be the right answer? A. A is the right answer. Now come to this. So what it is? Static indeterminacy again. So how many cuts? 2 cuts. So 6 minus 2 because of this roller and minus 2 because of this roller. So 6 minus 4, 2 is the answer. Is it okay? Very simple questions have been asked. A statical determinate structure. What is it? Cannot be analyzed without the correct knowledge of modulus of elasticity. No. We don't need modulus of elasticity. Must necessarily have roller support at one of its end. No. I give you an example. Cantilever is a determinate structure and no roller. So this is also wrong. Require only static equilibrium equation for its analysis. Yes, this is right. Will have zero deflection at its ends. No, not necessarily. Right. So what is the right answer? C. Come to the next problem. A statical determinate structure is the one which cannot be analyzed at all. No, we analyze it. So statical indeterminate structure we can analyze. Can be analyzed using equation of statistics. No, we need additional equation. Can be analyzed using equation of statics and compatibility. Yes, right. So this is the right answer. Let us read fourth also. Can be analyzed using equation of compatibility only. No, we need compatibility and equilibrium equation. So which is the right answer? C. Now see the next question. What is the statical indeterminacy for the frame? Now let us solve it. Again I will use the cut method. 3, 4. So I have 4 cuts. So 4 into 3, 12. And because of this, I have -1. Is it okay? Clear? So the answer is 11. So answer is 11. Now come to the next. So he is asking the independent degree of freedom. So kinematic indeterminacy. So how many I have? 2 here, 2 here and 0. So what is the answer? 4. Now kinematic indeterminacy of this. So what is here? 3, 3, 3, 3, 3, 3. So how much? 18. And then 2 here and 1 here. So how much I have? 21. Ignore the axial deformation. So how many member? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So minus 10. So what is the answer? 11. So 11 is the right answer. 11 is the right answer. Now if the axial deformation is neglected, what is the kinematic indeterminacy of a single bay portal frame? Okay, he has not say about the story. So भावनाओं को समझो. It is single bay, single story. Is it okay? Clear? So what is the kinematic indeterminacy? 3 here, 3 here, 6 minus 3 because of axial deformation. So the right answer is 3. Now the next, the number of independent equations to be satisfied for static equilibrium in a space structure. For I have discussed in my videos that space structure we need 6 equations. So what is the right answer? It is B. Now see the next, the kinematic indeterminacy. Hinge gives kinematic indeterminacy of 4, 3 here and 1 here. So how much I get? 8. So 8 is the answer. Now let us do another. So the kinematic indeterminacy of the beam. So 1 here, 4 here, 2 here, 2 here. So what is the total? 9. Now static indeterminacy. How many cut is required? 1, 2 and 3. So 3 into 3, 9. Okay, minus 1 here and minus 2 here. So total minus 3. So what is the answer? 6. So 6 is the answer. Now see the next one. A simply supported beam shown in the figure. Okay, so this is simply supported. Oh my god, it both have the roller. Just observe, both are the rollers. Is it okay? So let us see. It is what it is given. I think that's okay here. So first is it is determinate and stable. No, it is determinate but it is unstable because of roller. Okay, so this is not the right answer. So make it wrong. This is not the right answer. Okay, now come to the second. Determinate and unstable. Yes, this is right. Let us read another two. Indeterminate and stable. No, it is not indeterminate. Indeterminate and unstable. How can it possible? So the right answer is B. Now let us see this. So he is asking kinematic indeterminacy. 4 here, 3 here and 1 here. Is it okay? Clear? I have told you how we arrive at the 4. Is it okay? It is how much? Theta here, delta x, delta y. So for hinge I have 4. For this joint I will be having theta only, theta, delta x, delta y. We can say it is theta 1 and theta 2. So 4 unknown here and here I have only 3 unknown. Is it okay? Here I have only theta unknown. So 4, 3, 7 and 1, 8. Now ignore the axial deformation. So what we will do? We will subtract the number of members. So what is that? Ignoring axial deformation. Is it okay? So how many members? 3. So 8 minus 3, 5. Is it okay? So 5 is the answer. Now see again kinematic indeterminacy. So 3, 3, 3, 3, 3, 3. So how much you get? You get 18. Plus because of hinge you will get 1. Because of roller you get 2. So how much is total? 21. Now how many members are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 members. So what is the right answer? 11. Now there may be some error. So it is not 3 in the engineer. I have seen 2-3 books, all have written 3. So there might be some error in the engineering services exam. If you see the static indeterminacy, then what is the static indeterminacy? You make 4 cuts. So you have 12. 4 into 3, 12. Minus 1 for hinge and minus 2 for roller. So minus 3. So how much you get? You get 9. So what should be the answer? 9 comma 11 should be the answer. It should not be 3. So make it 9 comma 11. Or if you have to choose the best, then I think this is the best. But it should not be 3. It should be 9. I think you might have got the bonus marks. Okay. Now come to this. Axial deformation is ignored. Okay. So you have to find the kinematic indeterminacy. So what will be the kinematic indeterminacy for this? Make 3 here, 3 here, 6. Ignoring the axial deformation, 3. So what is the answer? 3. So kinematic indeterminacy. Okay. So 3, 3, 3, 3, 3, 3. So you get 18. 18 plus 1 plus 1. So how much? 20. Is it okay? Now, how many member? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 members. So how much is the kinematic indeterminacy? It is 10. So these all are straightforward question. As you are able to see, you don't have to put much effort. Okay, now it is again static indeterminacy D and kinematic indeterminacy. So what is the static indeterminacy? If you cut here, again it is a gate question actually, and there might be a bonus marks in that here. So if you cut here, it will be 3 minus 3, because 2 here minus and 1 here. So what you get? 0. So no option of 0. Now let us find the kinematic indeterminacy. 3, 3, 6, 6 and 2, 6 and 1. So you get 7, 7 and 2, 9. Is it okay? So no answer is matching. So what will be the right answer? 0, 9 is the right answer. No answer matches. Okay, this is a gate question. So now the static indeterminacy. So how many cuts? 1, 2, 3, 4. So you can cut it into 4 cuts. For 3 trees by 4 cut. Is it okay? Then minus 1 here, minus 2 here, minus 2 here. So 4 into 3, 12, and then minus 5. And minus 1 because of this inch, minus 1 because of this inch. So minus 2. So what is the total indeterminacy? It will be 5. Is it okay? It is a good question. The degree of static indeterminacy. Again, it is very simple. If you do 2 by this, 1 and 1. So 4, 4 minus 3, equilibrium equation, and minus 1 because of this. So what you get? 0. So friends, if you see, in all the level 1 question, I have taken approximately 40 or 50 seconds at the max to solve this. So if you watch my videos and do what I am doing, then you can also able to solve the question in such a pace. Now let us take, there are very few, but at least I suppose in engineering and if you gate you match, there are 8 or 9 questions which are little bit tricky or which need little bit of what you can say observation to solve the question. So I have just separated those questions and I am solving those questions for you now. So let us put little bit of more time and energy on these questions. So what it says, neglecting axial deformation, the kinematic indeterminacy. So if you see the kinematic indeterminacy, 3 here, so 3 here, 3 here, 3 here, and 3 here. Is it okay? Then how much here? It will be plus 1 plus 2. Now what is this? This is a fixed support with a roller. Okay, this is a new type of support. I have not discussed this support. So what is this? This is a fix, means it will resist the movement. It will resist the vertical deflection also, but it allow the horizontal movement. Is it okay? So how many reaction I will have? R, V and M. But I will not have any reaction in horizontal direction. So what is the degree of freedom? 1. So it has a 1 degree of freedom. So if you see anywhere these type of support, then this is known as somewhere it is known as guided roller, or you can say this is a roller with fixity. Somewhere, some books you will find its name as guided roller. Okay, so it gives 2 reaction and 1 degree of freedom. Clear? So how many degrees of freedom now I have? 4, 5, 6, 7. So 21 here and 4 there. So how much? 25. Is it okay? Now ignoring the axial deformation. So how many members I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 members. So what is the answer? 14. So this is a good question which I have not able to discuss these type of support in my notes or in my videos. So this is the best place to discuss these type of things. Now see this following statement. Now what it says, a statically indeterminate structure is not economical from the material standpoint in comparison to statically determinate structure. No, as I talk in my notes also, we cannot comment on the economy. I write it, it is very important, it has asked in many times interview also. Economy is not decided on indeterminate or determinate structure. I can have a determinate structure which might be costlier than the indeterminate structure and vice versa. Is it okay? So this is not correct. If n redundant in a statically indeterminate structure of n degree of static indeterminacy are removed, the structure will become statically determinate but unstable. Let us read again, this is important. If n redundant in a statically indeterminate structure, so there is a structure which is n indeterminate. Let us make it a simple and let us say its indeterminacy is 1. Okay. Now I put it roller. Okay, so its static indeterminacy is 1. Now I will remove this. So I am removing the roller. Okay, so n degree of static indeterminacies are removed. So what I am doing? I am removing the roller. Okay, the structure will become statically determinate. Yes, structure will become statically determinate. It's very correct because now structure is like this, but unstable. No, it will be stable. So this is also wrong. Now see the third one. In the rigid frame analysis, the axial effects are ignored as their influence is negligible, small compared to bending and shear effect. This is correct. Okay, we mostly ignore, I have discussed in my videos also that we ignore the axial deformation because there is not much influence of axial effect. So what is the right answer? Only 3. Okay, now see the next question. The number of unknown to be determined in the stiffness matrix is equal to static indeterminacy, kinematic indeterminacy, the sum of kinematic indeterminacy and static indeterminacy 2 times the number of support. No, the answer is kinematic indeterminacy. In my first video, I have discussed the methods to be used. If you remember, I have discussed 2 methods. Force method, which is also known as flexibility method, and which is also known as compatibility method. Okay, and second was displacement method, which is also known as stiffness method, and which is also known as equilibrium method. So in a stiffness method, stiffness, so displacement, so what is the right answer? Kinematic indeterminacy. This is a good question. Good question. Fundamental question, but asked in a very nice way. Now see the next one. So a prismatic beam is shown in the figure. Consider the following. A prismatic beam is shown in the figure. Now what it says? Consider the following statement. So this is the beam. So what is its static indeterminacy? 2 here, 1 here, 3 minus 3 minus 1 because of hinge. So minus 1. So it is unstable. So the structure is unstable. Very correct. The bending moment is 0 at support and internal hinge. Okay, right? No issue. It is a mechanism. Yes, it is a mechanism. Is it okay? It is statically indeterminate. No, it is not statically indeterminate. See, now what is a mechanism? I will not take much on this, but I will discuss this when I will be discussing the plastic analysis. So don't worry, but I give you one idea that if you have 3 hinges one after another, then that is a mechanism. Right now, this is sufficient for you to know that if I have 3 hinges, one hinge, second is internal, and third is the roller. All 3 are treated as internal hinges. Hinges. So if you have these 3 hinges, then it is a mechanism, and mechanism is always unstable. It will fail like this, okay, linearly. So I will discuss this when I will be discussing the plastic analysis. So up to that, you only remember this and your problem will be solved. Now, a frame is given, analyzed by slope deflection method. So what it says, it is asking? Number of unknowns. So how many unknown I have? 3, 3 and 2. So how many I got? 8. Now what are in a slope deflection method, what we do? We ignore the axial deformation. So minus 3. So what is the answer? It is 5. Is it okay? Now come to the last few problems. What is the total degree of indeterminacy? This is the super question. Many people might become into the trap. It is a good question. Here is that the loading is vertical. You have to observe that the loading is vertical. Is it okay? So what is the total degree of indeterminacy? Prismatic beam shown in the figure. Now when loading is given, if you see, the loading is vertical. So I have 2 reaction here, 1 reaction here, 1 reaction here, and 2 reaction here, because all the loading will be vertical and I will be having movements at the fixed end. So what is my total unknown? 6. Now what is the equation available? If I have removed summation h, so I have only 2 equation available. So my total indeterminacy is 4, and this is the answer. So this is a very good question, friends. Just keep an eye. The observation is that we mostly write 3, 2, 1, okay, and then 3. But this is not the case because he has given the loading. So the observation is about the loading. Okay. Now see another problem, which is also a good problem. The degree of static indeterminacy for the rigid frame as shown. Now if you see this frame like this, then what is its static indeterminacy? It is 3. But now there is a member which is joined here. This is known as bracing. These are known as bracing. These are bracing. Is it okay? So they have the internal hinge at these points, at their own. The internal hinge is not at the junction, but little bit inside the member, inside the bracing. Is it okay? So I don't get any additional equation, but at the same time I get 2 more unknown. One unknown is this and one unknown is this. Axial force in these 2. So what will be my static indeterminacy now? 3 for the normal plus 2 because of this and this. So my total is 5. So this is a good question. Now see this, I have discussed in my notes, so it becomes easy, but still I want you that you put little bit of weightage on this question. So static indeterminacy. So what is the static indeterminacy? 2 here, 1 here, 2 here. So total 5 minus 3. So how many you have? 2. But if you have one link which is joined by 2 hinges, then you have how many additional equation? 2. So what is the static indeterminacy? It will be 0. I repeat, what is happening? 2 is the static force in hinge, 1 force in roller, and 2 force in again hinge. So total 5. Equation available 3. So I get 2. Is it okay? Now because of link which is joined at 2 hinges, so this hinge give 1 additional equation and this hinge give 1 additional equation. So 2 minus 2 0, and this is a statically determinate structure to be solved. Is it okay? Now see this appeared in the GATE examination. So what it says, that there is a rope which is connected. Is it okay? So it is asking the static indeterminacy in this. Is it okay? So a rope is added. This is a hinge. Clear? Okay. Now let us take the last two questions. So this is a rope and this is my frame. Okay, and he has been asking the static indeterminacy. So let us do it very simple. If I make one cut, then I have 3 minus 1 here, minus 1 here, and this is a hinge. Is it okay? So this is a hinge. So minus 1 and minus 1 due to hinge also. So my static indeterminacy is 0. So what is the answer? 0. Come to the last problem. This is a tricky problem asked in GATE. So it has been asked to find the static indeterminacy. At a first glance, it looks like a 3-dimensional structure. But if you just rotate this, you will see that this is like this. Okay, this is something like that. Just try to rotate it. Is it okay? So this is very simple. 1 cut, 3. Is it okay? Clear? So the answer is 3. Clear? So it is just a tricky question in which you have to just rotate it or see it from this side. You will see that it is a 2-dimensional frame. It is not a 3-dimensional frame. It is a 2-dimensional frame. So thank you friends for patiently watching my video. If you like my video, please subscribe to my channel and give a thumbs up. If you want any comment or if you want any explanation, then just write below in the comment section, or you can WhatsApp me on my number.